Hi girls, so today I'm recording a video on the beginning of the Chapter 18 Classification of Living Things PowerPoint. If your class was the one that already started this chapter, you will have to skip forward to the notes that you haven't done yet, and I will tell you in your assignment about what minute that starts. Or you can just fast forward until you get there. So what I will do is I will say next slide before I hit the next slide, and if you're taking notes, you can pause the video and write the notes down. That way you can listen to what I'm saying and also take the notes, and we won't have to retake these notes in class. All right, so why do we classify animals, plants, any kind of species? This chapter is going to talk about taxonomy and the classification of species. If you have ever seen this animal, you may have heard of one of these names. It's called the mountain lion. It's called the puma, the cougar, the catamount, the Florida panther, the devil cat, the screaming cat, and the ghost cat, depending on where it's located. Actually, there are 50 common names for the mountain lion. So if you thought a Florida panther, a puma, a cougar, and a mountain lion were different animals, you were wrong. They're all the same animal with a different name. Why is this a problem? This becomes an issue when we all think of animals as different when really they're the same, or when you're trying to talk about animals in a different country and they have a different name for them. There's lots of animals, like the bobcat is called the bobcat or the lynx. It has a couple names as well. So many different animals go by different common names. Next slide. The real name. So what's the scientific name for the cougar, Florida panther, mountain lion, catamount animal? Its Latin name or scientific name is Puma concolor. Next slide. So why are we classifying? We classify to organize the 2.5 million species that we've identified. Not that there are 2.5 million species, but there are 2.5 million species that we have classified as scientists. And that number is growing. Every year we find new species, particularly insect species. But we have also found new species of frogs, new species of mammals a few years ago. We've found new species, lots of new species that live in the ocean, in the bottom of the ocean. Small insects, we found lots of species of mites, spiders, things like that. We classify animals to easily communicate. So I can call this right here a polychaete worm, which it is, but there are many species of polychaete worm. I wouldn't call it a fireworm, which is a common name for it. I would call it a polychaete worm, so that somebody reading a paper about it in France, somebody else reading a paper about it in Japan, and somebody reading a paper that I wrote about it in Australia would all know what I'm talking about. So it's for communication. Everything has the same name no matter where in the world you live. And it also shows evolutionary relationships. So when we break down the classification of a jellyfish, it has a class, an order, a genus, a species. It can be broken down, and we can see if a jellyfish is related more closely to a squid or related more closely to a tunicate, or related more closely to a parasite, a leech or a bloodworm. I'm not sure what that is. Or related more closely to a nudibranch, which are those brightly colored kind of sea slug things that we talked about. Or here's a water bear. So is a water bear more closely related to a crab, or is it more closely related to a true insect? So we can look at that when we break down the classification and see what category these animals are under. This also works for plants. Animals are not the only things we classify. And then taxonomy, by definition, is the branch of biology that classifies and names organisms. If you're a taxonomist, and you discover a new species, you can name that species. And there are people whose job it is to find new species, and when they find them, they identify them, they publish a paper, and they get to name them. Next slide. All right, so the history of classification. There was a scientist named Aristotle, who I'm sure most of you have heard of. He lived around 300 BC, and he was one of the first scientists or first people to organize living things into groups called plants and animals. And he broke the animal group down into those that lived on land, lived in the water, and lived in air, or flying, swimming, and walking. He also broke plants down into 3 categories: small, medium, and large. The issues with that was that some swimming and some flying animals were actually more closely related, like a penguin swims, but it's actually a bird, so it's more related to the flying animals than a fish that swims. So he didn't quite have it right. And the thing with plants was a small plant could grow into a large plant and be the same plant, just earlier in life. So that wasn't quite accurate either. Many hundreds of years later, thousands of years later, the Swedish botanist Carolus Linnaeus improved this system. He totally broke it apart and restructured it and changed the way that we classify plants and animals. His system looks at similarities and differences physically of plants and animals, and he created a classification system based on hierarchy, meaning starting very broadly with a kingdom and becoming very specific with a species. He developed a 2-word naming system called the binomial nomenclature. The binomial nomenclature is broken down. The first of the 2 words is the genus, and the second of the 2 words is the species. So for our species, it would be genus Homo and species Sapiens. So we are Homo sapiens. That is our binomial nomenclature. That's what we call humans. For the cougar that we looked at a few slides ago, it would be Puma would be the genus name, and concolor would be the species name. And you wouldn't call it a concolor, just like you don't call us a sapien. You use both words when naming a species. This works for plants as well. Oh, sorry. Next slide. Okay, so Linnaeus's classification system gets broken down like this. D, K, P, C, O, F, G, S. Dear King Philip came over for good soup. You can change that sentence to whatever you want, as long as you know what it stands for. The first one is, then the D stands for, sorry, I'm not writing on the board, I'm writing on my screen, which is a little harder, the domain. K, kingdom. P, phylum. C, class. O, order. F, family. G, genus. And S, species. There are only 3 domains of life. Then we start getting more specific, like kingdom, and kingdom is like animal. Animalia is a kingdom, animals, and plantae, or plants. P is phylum, class, order, family, genus, species. So it goes domain, kingdom, phylum, class, order, family, genus, species. However you want to memorize that, but you do have to memorize that for the quiz on this chapter. Let's look at an example. So next slide. So here's an example. This is the kingdom Animalia. You'll notice all of these words until order end in That's a Latin thing. So the kingdom is Animalia. That's all animals go in that kingdom. It's very broad. After Animalia, we get the phylum. The phylum is Chordata. So chordata is anything with a backbone or a vertebrate. So vertebrates are all chordatas. So you can see we eliminate the, oh, it's going to change. Sorry, that's an accident. We eliminate the lobster and the spider and the coral and the mussel and the jellyfish because they do not have spines. They don't have backbones. So now our chordata are all in this group. Then we go to class. So kingdom and phylum. Now class is Mammalia, so all mammals. Birds aren't mammals. Dolphins are mammals. Sorry, sharks aren't mammals. And fish aren't mammals. And alligators aren't mammals. So fish, reptile, fish, bird. Not in the Mammalia group. Order. So the order is Carnivora, so that's animals that are carnivores. Obviously a rabbit is not a carnivore, so it doesn't get to move to the next group. Bats are not carnivores, dolphins aren't carnivores, hopefully koala bears aren't carnivores, neither are moles or skunks. So now we have a smaller group, we're getting more specific. Carnivora. Now we have the family. The family is canines or Canidae. So now we get rid of the cat. Cats are Felidae, they're felines. And bears. Bears are not carnivore, canines. They are just carnivores. After we get to the family Canidae, we move towards the genus and species. Now we're getting more specific. So the genus is Canis. This is a specific group of canines. The foxes are not part of that group. And now we're looking at the species level. So the species is Canis lupus. This is a wolf. A wolf, common name wolf. The species name is Canis lupus, and it is the most specific level of a species. Next slide. Two-part name. So here's the notes on binomial nomenclature. Binomial nomenclature is two parts. The first is the genus. A genus definition is a group of similar species. The second part of the name is the species. A species, by definition, is a similar organism that can reproduce together and create fertile offspring. It has to be able to create offspring that can then continue to have more children. So this is a, oh, sorry, it's going to switch again. Wrong way. This is a, I got to turn the pen back on. Mule. A mule is a donkey and a horse who had a baby. Now you might say a donkey and a horse aren't the same species, but they can reproduce together. So why aren't they the same species? The answer is because this mule cannot have children. It cannot reproduce. It's the end of its family line. Horses, donkeys can make mules over and over again, but a mule and another mule cannot make a mule. So that means they don't meet this criteria, creating fertile offspring. Another example of that is the coy dog, which is when a coyote and a dog mate, and they can have offspring called coy dogs, but coy dogs also can't continue to mate forever. So eventually they become what we call sterile, and they don't meet that criteria either. Examples of the binomial nomenclature are Homo sapiens, Homo neanderthal, and Homo erectus. They're all in the Homo genus, but they're all different species. Okay, next slide. I think I'm going to run out of time at 15 minutes. I'll have to make a second video, so I'll cut it off. This is the last thing. So Linnaeus wasn't able to do research on the molecular level. They didn't really have great microscopes back then. He didn't know too much. So instead, what he had to do was he really focused on the eukaryotes, the plants, animals, fungi, big things, kelp, things like that. But we've also found that there are two other domains of life, the eubacteria and the archaea. These are our prokaryotes. They have no nucleus. Everything with a nucleus, every single eukaryote goes in this domain, so almost all the things we'll talk about go here. But the other two domains are eubacteria and archaea. and the video is going to cut out.